Question 4.6. Circuits shown in figure P 4.6 can function as logic gates for input voltages that are either high or low, using 1 to denote the high value and 0 to denote the low value. Prepare a table with 4 columns, including all possible input combinations and the resulting values of x and y. What logic function of x is a and b? And what logic function is y of a and b? For what values of a and b do x and y have the same and or opposite values? So let's go with the first case, A is 0 and B is 0. And let's just assume both of the diodes are on or off. We'll see what happens, right? So if you assume D1 is on, this is a short, so X would be equal to 0. And if this is also on, X would be equal to 0, and it would all work out well. So let's go ahead and say that's good. What about the next case? A is 0 and B is 1. So let's assume D1 is on. If it's on, X is equal to 0. And if X is equal to 0 and B is equal to 1, then the current would have to go that way. In the way it doesn't go, and so this would be off, and that would all work out. So I would say X is equal to 0. But let's just double check. Let's just double check. We assume D1 was on there, right? This time let's assume D2 is on. If we assume D2 is on, this is a short, X would be equal to 1. And if X is equal to 1, and then A is equal to 0, then this would conduct, and this would short, so X would be equal to 0. Ta-da, it does work. It does work to just assume one is off or one is on. Let's go. Alright, let's do the next one, where B is equal to 0, A is equal to 1. Assume, honestly, because of the symmetry in the circuitry, you can just tell that it's going to be 0 again. But you can carry that out if you want. Alright, what if they're both 1? Let's assume D1 is on, or whatever. So if it'll short, it'll be 1, and so this would be the same voltages here and here, so that'd be a short, right, or whatever, so that would be 1. It makes sense to me, so that's the quality you get on this channel. Alright, so that's an AND gate. That's an AND. Okay, and I'm guessing this is maybe an OR, but here, let's go. 0, 0. Assume D3 is a short. If it's a short, Y would be equal to 0. And if Y is equal to 0, then that's okay, that all works out. Alright, what about if B is a 1? If B is a 1, let's assume D3 is on. So Y would be equal to 0. So then that would be higher than that. So that would conduct. So then this would be a 1. And then a 1 would be greater than a 0. So this wouldn't happen. This would be off. And that works out. So Y would be a 1. And you can see in the symmetry, you can see because of the symmetry in the circuit that if you flip this and made this 1 and made this 0, the same thing would happen. And then let's make them both 1. Let's assume this is on, it'll short, so Y would be equal to 1, and then that would, there, done. Alright, ta-da. So this is an OR gate. For what values of A and B do they have the same value? For not A and not B, they have the same value, and for A and B, they have the same value. There, so this one right here, and this one right here. Wait, in different value? Okay, so this is the same, and for these are different. X, I mean, if you want to give it a logic gate, this is kind of a waste of my time, isn't it? Yeah, there you go.